Then yeah, so we'll start off by coming to a conclusion on the namespace selector issue, and then we'll talk about how to go from here to basically alpha release completeness. Yeah, let's get started with this. Let's get started with allowed namespaces, and we'll go to the next step from there. All right, so let me start by sharing my screen. Okay. Okay, so last meeting we discussed, we talked about bucket sharing, and after a long discussion, we basically came to the conclusion that the best way to go forward with bucket sharing or access restriction for bucket sharing would be by using this list of allowed namespaces. There was another idea put into the mix, which was to use a namespace selector rather than a list of namespaces. So namespace selector is very similar to how say services select pods, um, or any other selector in the Kubernetes API system. Um, it seems more intuitive, though it is a little more involved. There's a little extra work to be done to specify what the namespaces are. The benefit of allowed namespaces is with a selector is you can add selectors retroactively to namespaces where you want a bucket to be accessible without editing the bucket itself. In case of
Wait,
allowed names,
say that again.
so if you have if you use the selector, then you can add a new namespace, or you can allow a new namespace to access the bucket without changing the bucket object itself.
But what's the mechanism? How does one namespace get included and one not without editing the bucket?
With a label, right?
Label,
Okay. Okay, so the admin could create a namespace with a label, and implicitly that namespace gains access to a bunch of buckets, but ordinary users couldn't avail themselves of that.
Right.
So okay. Yeah, I like the selector style thing, as long as there's like a a brain dead way to do it, which is just an enumeration of the namespaces by name. And as long as there's obvious ways to get the null set and the universal set specified.
Okay, what? Go ahead.
Those are two obvious use cases that need to be relatively easy.
Okay, so
How do you get every namespace to get selected with a selector? That I don't know.
Yeah, that's what I was getting to.
Oh, well, I presume there's some selector that just says match star or something. I don't know how to do it, but
There's match labels and match expression, right? There's the
right,
two.
but can you match an expression that's trivially true, therefore it was always matches?
Maybe. It could be. We need to see
Yeah.
which fields the selector can use in the expressions.
Is it absolutely needed to have that universal selector?
I mean, I'm sure users will ask, right? They'll say, look, I created this bucket. I want everyone to use it. I don't want to have to muck around with anything complicated. Just tell me how to share it with everybody. And it would be nice to be able to have a simple answer for that guy that doesn't involve something like, yeah, put a label on every single namespace and then match that label. Because like that's just more work from someone's perspective who just wants to share it with everybody.
Yeah, I agree. We can look it up.
Yeah.
Sure, we can find something. It's not sure if it's going to be trivial or expected, but I can look it up.
Okay. And then the empty set case, or the singleton case, is, if when the sidecar is provisioning new buckets, we have to put something in this field that matches exactly one namespace, which is the namespace that the bucket request was in. And so we need to know that that is also something that's really straightforward and simple to do, so that every time you create a bucket request and one of these buckets pops out, it already has a populated allowed namespaces that matches Or actually, maybe it can be the empty set because it's already bound to the BR, so you don't need any allowed namespaces in order to allow that BR to function correctly. So
Right.
maybe for dynamically created buckets, this really is empty.
Right. I think so. That was my thinking, that the BR reference doesn't require selecting a namespace. But
Right.
hope it's consistent enough. But
Well, what it means is that the guy who has the BR can't just create BARs that point directly to the bucket. He always has to go through his BR, because if he did create a BAR that pointed directly to the bucket, it would fail to match the namespace, and it
right,
wouldn't work.
he could do it if he changes the selector to match as well. But it's like on it.
Right,
Yeah.
but we're assuming that ordinary users don't have access to touch these bucket objects. They
The
can
bucket
just
class, you mean?
no the bucket.
Allowed namespaces.
Ordinary users cannot see the buckets. They can only see their BRs and then the name of the bucket that their BR got bound to, but they can't see the object itself because it's a clustered object.
Right.
I mean, that's how PVs are, right? You cannot see, ordinary users can't see PVs. They can only see the PVCs and the name of the PV that their PVC got bound to, because that's part of the PVC spec. But they
So
can't see the contents of the.
Are you saying that BR should be the way to access the B?
For the ordinary greenfield use case, yes. Like if you just create a BR, it will get bound to something, but you should never care about the details of the thing it got bound to because your handle is the BR.
Right.
It only becomes interesting when you're trying to share it and then someone else has to find a way to reference this thing. But you have the bucket name because it's in your BR after it binds. And then you could give that to someone, and if they have access, which they won't know unless they can see the buckets, then they can try to create a BAR. Or there's some other controller that automatically facilitates the granting of access that we can design later.
Just one point. With a list, it's the same issue, right? With list, like if we had just list of names, namespaces names, that will be these two issues that you just raised. The select all is also a problem. You have to have some other flag or something, and also the how to default to select myself or something like that.
Yes, I totally agree. So the allowed namespaces selector has no downsides that the allowed namespaces list doesn't also have. So I think it'll work fine.
Right, but I agree that these two cases are interesting to close, like the detail for sure. I think it's useful to have all and myself, like it's just to understand how this should work for users. I don't know the answer right now. I don't have any suggestion.
I mean, myself seems like something that's always supposed to be true.
You mean the singleton list?
Well, no. Regardless of what, how many namespaces you're allowed to is allowed to have access to the bucket, the namespace that created it always should have access to the bucket.
Oh, right, but in the brownfield case, there will be no namespace that created it. The admin will create it, and it will not be bound to anything. It'll just be floating there for people to use, but there will be no BR whatsoever, right? If it's a pre-existing bucket, you don't need a BR. You just create the B. There's no namespace associated with it.
Right.
So,
I'm saying we don't need to come up with some mechanism to say that only me. That only me is implied. So even if there's nothing specified, that implies only me.
Okay.
I think the question was when I want when it's me that created the BR as well.
Yeah.
Do I also get away with referencing the B directly?
Oh, I would say no. I would say that the controller that's dealing with BARs and trying to bind them, if your BAR specifies a BR, and it's in the same namespace, you're done, right? That is your access check, is that the BAR and the BR are in the same namespace. You don't need to perform any additional checks. It's only if the BAR tries to refer directly to a B that you would even need to consult this allowed namespaces field to see if you're allowed to do it or not. So
it makes sense, but the one unexpected thing about it is that something that usually works for others doesn't work for me. That's kind of I think that this is why you raised it, right?
But if I had a BR, then this is the greenfield case, and I created it, and I don't expect to be able to create BARs that point directly to the bucket, because in that use case you're pointing them to the bucket request, or the bucket request, the BR. And
so the question is just if deploying, if it makes a difference that I need to deploy differently based on if I created a BR or not. That's if it matters to anybody. Well, but anybody can fix it. Like if we explained it this way, I'm sure that it's, you know, any deployment can be done.
So the brownfield case that I'm most interested in exploring is I've heard whisperings and suggestions that at least some people are thinking about creating a backup API that will layer on top of Cozy, such that you'll have buckets that Kubernetes knows about that will be targets for backup operations. And in such a context, you will probably have buckets being shared across namespaces, I think, because I'm just imagining a hypothetical backup architecture where you have, you know, a bunch of different users and they're shoving data into some backup service. You probably just want to have one bucket that everyone shoves their data into, and then you have some backup service that knows how to sync data and source data from that bucket. And so then in such a hypothetical world, how does everyone get a reference to the bucket that they're going to be using for their backup target? Like, is it I don't know, like it feels like a fairly concrete use case that is probably coming soon. And
that's a very valid use case. That's a good use case.
I suspect that some of the people in the data protection working group are interested in Cozy mostly for that reason. But I haven't thought through all the details. So, I mean, it obviously makes sense that, you know, backing up to object stores is a you know, very obvious thing to do.
We could
so who needs the access, though?
So talking about a concrete use case, definitely that we definitely need that multiple namespace access the same, multiple users using the same bucket.
Well, or
I think that we definitely would do. So
they'll be referring to the same bucket. Again, like without having a prototype backup API to think about this, like I don't know what you would do. Would you have some sort of a separate object for the backup API that would refer to a bucket, or would you individual backup requests refer directly to individual buckets or bucket access requests? I mean, I haven't thought it all through, but like that feels like a use case that we don't want to screw up. Let me put it that way.
Right.
Whatever we do, it should be possible to layer a backup API on top of Cozy. And it seems fairly obvious that the brownfield use case will be necessary to make that work, because no one wants to create their backup target as a bucket request inside a, you know, an individual namespace, right?
Right.
Have this bucket that basically lives longer than the cluster, most likely, because the part of the reason for backing up is your whole cluster might go up in smoke and you need copies of your data so you can restore your cluster.
So Ben, so that actually brings a bigger question, and it kind of leads to something that we were talking about earlier. But before we go there, can we like decide on this?
Well, so what I guess what the leap I'm trying to make is I like this allowed namespaces selector model, but I want to zoom out one level and say, just take a look at the whole brownfield workflow.
No, we'll do that, but without going there, I think we can still decide if we want to, or how we'll do the allow all or allow nobody but myself.
Well, if you want allow, no one but myself, I would suggest that you just have
Leave
a
it
match
empty.
expression that matches exactly one namespace, and you explicitly put that namespace in it.
Sure.
Right.
Sure, that'll work.
That's the easy way to get a singleton allowed namespaces. The
Yeah,
empty
that'll work.
list, I think similarly, you could just omit this field, and that could be interpreted as match nothing, right? If there's no selector present, we could just say, well, then nothing matches.
But does the selector, I mean, when it starts, I mean, if I'm using a greenfield provisioning for it to begin with, right? It comes from a bucket class, right? The selector.
Yeah. Yeah.
So it's not that I can pick my bucket class to be only me. It's,
So yeah, that's true. So what you do
and
is,
the list is the same, right? It doesn't matter.
I'm guessing that most bucket classes would have an empty value here as well, because they would be intended for greenfield use cases where you're creating buckets that will only ever be referred to by their BRs and not by their buckets. For the ones that are created through the brownfield process, the bucket class is irrelevant because you're manifesting the bucket directly, and no bucket class will ever get referred to in that workflow. Unless, well, that's why I wanted to pop up a level and say, what does it look like to do the brownfield use case? Like, I'm in my imagination, it's just, kubectl create bucket, and then you give it some YAML, and then you're done. But like, maybe that's not what we want.
Yeah, no, but we said that there is a greenfield to share. I can share a greenfield bucket by creating it from a bucket class that has a label, for example, selector. That can be. I'm sharing it with all my friends, right?
Well,
the label of friends.
Perhaps, but like another alternative to do the green to brown workflow would be to say, you do the regular greenfield workflow and you get a bucket that has no allowed namespaces. Then you do something else, some other step that mutates your bucket to grant access to other specific namespaces that you specify, and then those users can do it. So we could make it a two-step process where you have to, rather than just picking the right bucket class, where you have to use some other object that we haven't designed yet to mutate the bucket to grant access to somebody else.
Right.
Be like some sort of bucket share object, or maybe there's some extra fields on your bucket request that you can specify to explicitly enable sharing on a bucket that you own because you have the VR. We could think through the green to brown use case.
So hold on.
Interesting.
No, before we go there, hold on. So so this is what I've got. So I want you to take a look at this, because there's a reason we've been going in circles. There's a reason we're not able to come to a conclusion, and the reason is quite obvious. Of the 3 use cases that I've listed here, we're only able to do 2, but not all 3, and we do 2 of them, and then we try to do the 3rd one, and then the whole thing breaks down. Maybe there is a solution to have all 3, but as of right now, it looks like we can do 2 of these very reliably and right. The 3rd one, we're not able to. So right now we're talking about bucket sharing. So take for instance, we give up bucket self-service. Let's just take that as an example, and then we only allow these 2. Only we support these 2 use cases, sharing and mutation. Giving up self-service would mean BRs are not namespaced. I'm talking strictly about bucket creation, not access.
Right.
So if there is no BR,
we can't give up self-service. I think that's obvious.
Well, I don't know if that's true. I really don't know if that's true, because I do believe that majority of the use case will be like the backup use case that you just mentioned, where it's brownfield. Greenfield seems very unlikely, and from seeing how everyone has done it so far, among all the customers that at least Minayo has, nobody is doing a bucket self-service. Bucket creation automation is not something that they're looking for really.
So for this use case, you're right. The self-service doesn't matter a lot. But if all we cared about was just having enough of a bucket API to support a backup use case or a sharing use case, like, we wouldn't have bucket create and bucket delete in our in our API.
Well, let me ask you this. So it can easily be addressed by having some temporary bucket that's cluster scoped and accessing it as a brownfield bucket. If it's just scratch space, does that make sense? You don't need to go through a bucket creation step in order to have a temporary bucket that you just want to use and pull down. There is no real use case like that, I think.
If you have some sort of a distributed app with multiple pods and multiple microservices and a bunch of components, and the glue that ties those together is some buckets.
Yeah.
Then in order for your application to be portable across clusters, you need the ability to just say, here are my pods, here are my PVCs, and here are my bucket requests. Go make all that real, and then wire it up together. And that's what the YAML specifies. And then my app is running. And if I want to tear that down on this cluster and go over to this other cluster and drop it there, and it just works again, like that, then you have portability.
Well, you don't lose portability by saying BR is cluster scoped.
I don't understand. What are you suggesting, that users cannot create buckets?
Yeah, I don't know if that's such a strong use case as we've been saying so far.
I mean,
why not?
I don't know. I'm not saying it's
then
not.
Why do we even need the bucket request? And if you don't really, if it's a,
yeah,
it's already
someone needs to be creating buckets, and you're by making a non-namespace, you're basically saying, well, the admin can do it, but then then you don't have a model where a user can go from one cluster to another and do things I'm thinking like namespace as a service models are becoming more common, right? Where you basically, I want to deploy some app, and you go to your ops people and they say, okay, here's a namespace in a cluster and you have access to it, go nuts. But they don't give you more than just one namespace worth of access to a cluster. They're not going to give you access to clustered objects, and they're not going to give you admin powers.
They still rely on a bucket class. People still have to rely on a bucket class, which admin has to go and create.
Yeah. So you need to be able to read storage classes and bucket classes. Well, if you want to be able to distinguish between them. I mean, the real portable use case is you leave the storage class blank and you accept the default. And similarly, you could leave the bucket class blank and accept the default. And that's the most portable thing you can do, is just say, hey, as long as there is a storage class or a bucket class, I'm happy with using it.
Then you get undefined behavior. Like I don't know if that solves the problem again.
Well, before we had raw block volumes, that really did work for storage. Like a PVC was a PVC was a PVC until we added raw block volumes. And even now, like very few people actually use raw block volumes, so we still get away with just saying a PVC is a PVC, on any cluster, and it just works. And yeah, if you want a raw block volume and the default storage class doesn't support it, then that's too bad. But it can support it, right? I mean, there's no reason that the default storage class can't support both kinds of volumes.
So okay, how does it? Okay, let's come back to this question of how important is self-service. I went and looked at what customers use or how customers use buckets, and no team is actually provisioning buckets on their own.
I disagree. I mean, in the cloud, every team is provisioning their buckets.
It's an admin. I mean, not the application users. Is that fair to say, Guy?
I don't think so. I don't think so. I think buckets are getting created by like many different types of users, not necessarily admins. It's not a, it's not a, how do you say that? Like it's not a sensitive resource. Like if you have access, if it's yours, you can get full access to it, right? It's not, you cannot really make too much bad things out of it.
Yeah, I mean, the worst thing you can do with a bucket is consume space that somebody has to pay for, right? So they can put quotas on you to prevent you from going nuts with space consumption. But aside from that, yeah, it's not a sensitive resource. So I mean, I have.
Okay, so let me ask you this. So in that case, since it's not very sensitive, is it okay to give users cluster roles to create buckets?
Not really. I mean, because then you don't have any kind of boundaries between Alice's buckets and Bob's buckets, right? If Alice wants to create a bucket that's hers and the Bob can't see, she needs to be able to do that. Just like PVCs, right? Like, because once you create a PVC and start putting data into it, all of a sudden now, if someone else gets a hold of your PVC, you're in trouble. As long as that PVC was empty, who cares? But the moment you start using it, it becomes sensitive. And I think the same is true of buckets, right? The moment you start putting data into the bucket, then now you care who can read it and who can write to it and who can delete it.
So in AWS, it seems like okay. Let's get. I'm just thinking this through. So
what do we gain if we go this route? What do we gain? Can you explain?
So yeah, let me explain that. So it seems to me like we can only get, again, I'm not even saying we go this route. I'm saying more like we're able to get 2 of these use cases right, but not all 3. So I was taking the example of not having self-service, and I was making a case for why we could go without self-service. Let's just assume that model where self-service is not needed, just for a second.
Well, this is following the historical evolution of volumes in Kubernetes, because originally Kubernetes volumes were also not self-service, and that was grafted on later.
Understood. Okay, so if you didn't care about self-service, if that was not a use case you cared about, then in that world, one of the ways to do it would be to have a BRB cluster scoped, or not even have a BR, since it's cluster scoped. In such a situation, sharing and mutation becomes really easy because all kinds of access.
You also don't need the class, or the bucket classes are not needed, because that's usually needed for dynamic provisioning. So
right.
Yeah,
right.
it's just getting very simple.
Yeah. Well,
right.
I think that this is how Kubernetes ended up with PVs originally, and then PVCs and storage classes coming later. And PVs were cluster scoped because, yeah, they were sort of a global shared resource.
So what I'm trying to say is, if we were to choose one of these use cases and said we won't do it, then we actually have a path forward. So far, the problem has been trying to convince ourselves and the reviewers that this will somehow work for all 3 use cases, and the answer to me seems like no. I don't think we should aim to do all of it right now.
Can we do bucket sharing without mutation? Is that required if we want to share buckets?
Yeah, if you didn't do mutation, you can do sharing and self-service. So that is, if
is the mutation that important?
So it seems like mutation is
that's
important.
the one I would drop. That's the one I would drop.
But can you explain again why if we drop, like, take one? I'm trying to figure out where we are stuck. I'm not sure.
Okay, so take self-service. We can go through all 3, but take self-service. If you didn't have self-service and you just have a bucket, no bucket request or bucket class, then all access to the bucket would be via BAR, pointing to that bucket, pointing to that cluster scope bucket. Just all access would be that way. In such a scenario, sharing is the same for greenfield or brownfield, and mutation, since there's only one copy of the bucket, it's very straightforward.
Well, to be more accurate, there is no greenfield because you can't self-service. So everything is just brownfield, and it's consistent. That's the benefit. If you remove greenfield and say it's all brownfield, you have consistency. And I'm actually sympathetic to this way of design, because you could dramatically simplify the API by saying, look, the only use cases we're after is somebody, bucket creation is out of scope. Somebody else creates the bucket and then tells Kubernetes about it. And all Cozy has to do is manage who has access to what buckets, manage minting of credentials and distribution of credentials and revoking of credentials, and making sure that information gets shoved into the appropriate directories in your pods when they try to bind to a bucket.
Maybe you can do this in phases. I'm thinking maybe you can do this in phases. Maybe you can do that too, right? phase
Mhm.
So
one.
that's why I'm
Yeah.
saying I'm sympathetic to this idea. You could say that's step one, but the moment you do that and you ship that, people are going to come back and say, well, this is all great, but I want to be able to create buckets too. And then you'd end up grafting on a provisioner after the fact, like what happened with volumes, right?
Ben, bucket creation is still possible. It's just not possible by the user. It's not out of band.
But I
I
thought
don't,
we solved the problem. I mean, do we still have a problem to have the bucket access request point to BR or a B? I mean, we said we can do that, and then it works. So by removing the greenfield or the dynamic provisioning here or the self-service, we are saying we are simplifying the model. That's true, but it's not that we are solving anything. We're just delaying it, and not sure if it's worth it. I mean, I think it's a
And are we making it harder to add it on later?
If our API has a single B, then we have mutation. We have a single source of truth for what Kubernetes thinks the backend bucket is. So,
but I think we've been in this model for at least a couple of months now. So I don't think are we even discussing a model where we have copies of the same B referring to the like clones of the B.
that model will happen when you do cross-cluster sharing.
I think Jeff's saying something. Jeff.
Sorry.
Yeah, sorry. Yeah. So all that's true. Technically, you have mutation if you have a single B. We can agree on that. And we've been discussing that for several months. But I think there's a nuance there that Sid and I talked about yesterday. And that is, if you have multiple users sharing that B, and then the admin changes the B, there's no consensus and those changes propagate to the back end. This might.
What do you mean users? Wait. What do you mean users sharing the B? What is that? You mean access?
Yes, multiple BAs pointing to that B.
Multiple BARs?
Yeah, that's what he means.
How do you prevent that? So even
BAR, but BAR does not sync back any data from the bucket. It's just an approval of getting access credentials for a pod. So what does it even relate?
Multiple applications have access to the same backend bucket through their BAR that points to this B, right?
Right.
Okay.
What's the problem with it then? If I mutate the B, what happens?
Yes, mutate the B, and that mutation propagates through the driver to the backend object store, right? And so.
What do you mean? What type of change propagates to the pod then?
So I'll help explain it. So if you did have self-service, and if you did do it by making changes to the BR, even deletion is a valid form of mutation. Let's say you deleted the bucket by having the BR be deleted, or any other form of mutation. What happens is all the other namespaces that rely on it now are basically controlled by another namespace, which probably doesn't even have visibility of who else is using it. It actually becomes an administration nightmare. But when you take this out, when you take out self-service and have a consistent model.
It's not consistent. You're just saying that it's the admin's headache to begin with, because there is no other way, right? The admin would have to be responsible for deleting a bucket and handling all the bucket access requests using it anyway. In that model where there is no BR, it's still the admin's responsibility.
But I thought we were going to get the best of both worlds with our model of greenfield and brownfield, where the greenfield solution was users have complete control over their buckets, and in the brownfield situation, the admin creates the bucket and there are no BRs, and so it's clear what's going on. It only gets weird when you do like green to brown transitions, and we could force people to make that more of a sharp break when they wanted to move from one mode into the other mode, instead of allowing some weird hybrid. We could say, look, you can be in one or you can be in the other. And if you want to jump from one to the other, you have to make a very explicit decision to like delete your BR to get there, maybe.
But it also happens if I delete a service. I mean, if another namespace relies on accessing a service that I created and I delete it from my namespace, it's the same thing.
Yeah. That kind of stuff doesn't bother me. The fact that one user can screw another user, that's just life. Yeah, that's why humans need to have human trust relationships, or the system needs to be built with the right levels of checks at a higher level to avoid those kinds of failure modes.
So if an admin wants to protect the other users, it can remove the BR. It can say you're no longer controlling the lifecycle. I'm doing that.
Yes.
And that.
We're losing the audio.
And what I actually had here. I was saying that, I don't know if you hear me now, but that I felt like we were closing on these three topics pretty well, actually. I didn't feel like we were failing on.
So Sid, maybe the trick is with this triangle you've drawn, you can break the line between bucket sharing and bucket self-service and say, you can have both, but you can't have both at the same time for a given bucket, right? You can either have a self-service bucket, which allows mutation, or you can have a shared bucket, which allows mutation. But if you want to go from bucket self-service to bucket sharing, you have to like jump over a gap, and you can't have them at the same time. It's like a switch with self-service or sharing, but not both. Which I thought we kind of had with the, creating buckets through BRs, the self-service model. By default, that's never going to be a shared bucket, right? Unless someone does something special. And similarly, if someone just creates a bucket with no BR, it's going to be shared, period. And there's no self-service around that. So like you're forcing people down one of those two paths. The only way to get from one to the other.
This is what Tim was saying. No, this is literally what Tim was saying. The cluster scope BR and the namespace BR. This is exactly what he's saying.
No, not a cluster scope BR. I'm saying namespace BRs, right? That's the self-service model.
Right. No, what I'm trying to say is that's where this idea came from. It's very similar to that idea. You're right. In the cluster scope, there's no BR. It's just B, no BC even. But in the namespace, you have the BR and probably the BC also.
Yeah.
Yeah, that would drastically simplify this model. I think it will solve a bunch of issues that we're dealing with.
But the only thing.
What are you trying to simplify? I mean, it seems like it works. It seems like it works. Even if I created the bucket, why can't I share? I mean, it's not that I want to mutate the list of shares now. That's not what I meant. But this is not what I mean to support. But why can't it be a shared bucket? I mean, from the bucket class, having a selector that says, I don't know, all backup applications can access it, for example, right? This is the label that I have in my bucket class.
Where I think things really start to break down is when you not only want to share across namespaces, but you want to share across Kubernetes clusters, where then, regardless of whether the bucket was created from a BR in one of those clusters or created outside, on all of the clusters other than the one where the BR is, it's going to look like a brownfield bucket, right? And then the question is, if you want to mutate that, you got problems, right? Because now you have multiple sources of truth on multiple Kubernetes clusters, and they're not talking to each other. And so you could lose out on any way of mutating that sanely once you go across more than one Kubernetes cluster. And I really want to be careful about talking about bucket mutation because it's this hypothetical thing that we have no concrete examples of. So it's not that I don't believe we could come up with some, but I feel like every time we talk about it, we don't actually pin down what we're talking about, and it makes it very hard for people to understand.
To solve that problem, do we just say bucket mutation's not allowed for brownfield, and then that solves that problem?
No, well,
but we don't know what. It's hard to say that without knowing what we mean by bucket mutation. Like which.
Well, we could minimally mean retention policy and some concept around allowed namespaces.
So can we just say what are the fields that we allow, and then the rest of them are not allowed to mutate, then that can simply.
Allowed namespaces doesn't actually change the bucket. It just changes the local Kubernetes cluster's policy around who can gain access to the bucket.
That's right. That wouldn't cause a driver call.
Yeah.
But I think retention policy, we need to allow that one to be changed. So yes, so that one is a yes. So,
can you say that again, Sheng?
I'm saying the retention policy, that one, we should allow that to be changed.
Okay, so let's say there's some field which is the retention. So okay, but retention policy isn't literally in our cozy spec. So it would be some opaque parameter on the
that, right?
class, right?
We have it.
It is
you mean the
deletion,
Kubernetes
deletion policy.
Oh, the deletion. Yes,
deletion.
yes. But that also also doesn't result in a driver call when you change it, right? It's just
right. Yeah.
If the deletion policy is set to delete and you delete the object, then we make the driver call to do the deletion. But if you don't, then we just never make that driver call. When we talk about bucket mutation, I think what most of us have in mind is something where like you make a request in Kubernetes on an existing bucket and some sidecar makes a call to some driver that goes and changes something on the actual device that's storing those bucket bits.
Right.
And no one has spelled out a specific example of like what that might be.
Yeah, I don't think we actually really talked about exactly.
Yeah, we've said like public versus non-public, or I mean, what about quotas? If we roll quotas,
exactly, yeah,
yeah. An example.
Bucket quotas.
But is that what it's going to pass to the bucket? So what? How does that work?
Well, yeah, so the bucket has a policy saying this is the maximum amount of space that it can store, or this is the maximum number of objects it can have.
Yeah.
Okay.
Stuff like that.
But is that something it's typically specified or typically left empty? Like when I create buckets on GCS, it never asks me how big I want them to be or how.
Bucket quotas aren't a thing in all object stores. That would be specific to only a few. I don't think even AWS has bucket quotas.
I think AWS has the concept of quotas. I'll have to look it up though. You might be right.
Can you just say those people can, if admin want to change that often, and I mean, out of Kubernetes, not through our API, then I mean,
this is
not
why
through
I'm
our
trying to get to the specifics, because I feel like it's easy if we have a specific example of what we're talking about. It's easier to say like, yeah, we need that or we don't need that. This feels like something that if we did it, it would be opaque because it would not apply to all buckets. It would just be some bucket class parameter that you would set that would be implemented by the driver in an opaque way. And if you and there's no way to really change opaque parameters after something has been created, at least not with PVCs. You can't change the storage class and have the PVC get updated. You just have to go straight to the back end and go make the change that you wanted out. The one thing you can mutate about PVCs in Kubernetes is the size, right? If you created 10 gig PVC, you can change your mind later and come back and make it 20 gigs, and Kubernetes will do that work for you. But it will not make any other changes to a PVC on behalf of the user.
I don't think we need mutation in this. It's what it's sounding like.
Mutation can be done out of band.
Yeah.
That's the one that I would let drop in this triangle and say, we don't have a specific example of a situation where you need to change some aspect of the actual bucket through Kubernetes after the bucket's been created. We can just say, look, after the bucket's been created, go change it yourself if you want.
But even if you did, it wouldn't be something you need to track or would care across users or clusters.
Right.
It would just be a fact that is what it is.
Okay, so that's a good answer. So in that case, sorry, go ahead, Jeff, whoever that was.
I just like that we clarified mutation, because there's some mutation that's Kubernetes specific, like deletion policy or allowed namespaces. And then there's mutation that would go through the driver to the back end. And what we're saying now is that any mutation that could involve the driver, we're not supporting it. It's an opaque type. Cozy doesn't care. And we're not going to have a controller looking for those mutations and invoking the driver. That type of mutation
for the foreseeable future, right? The worry is that
yes,
and that seems reasonable to me.
Yeah, same here. Hello.
Okay, so yeah. So Sid, why did you bring us to this slide? It was just to illustrate the
move
tension
forward.
here. Yeah.
Yeah.
So
Yeah.
what we can say is bucket mutation is the least valuable of these three things. You care about bucket sharing. We do care about bucket self-service. I mean, I agree in principle. You could take an approach where bucket self-service was like a V2 thing, but I don't think you can say it's something no one will ever want. At the best you could do is say we're going to postpone it till later, and I don't think that's a good idea. Just for
Perfect.
the success of Cozy, it's better to get it in and make it more valuable from the beginning.
Fair enough. I see where you're coming from. Okay, so in that case, we don't have to worry too much about, we don't have to worry about bucket mutation, and portability across clusters is simple now. Since we just don't do mutation through Cozy, it's always an out of band. So that being said, coming back to node selector, namespace selector. So we said we'll go with this approach, and we said in case of greenfield, it's pretty straightforward. You just copy over the fields from the bucket class. In case of brownfield, the admin goes and sets the list of namespaces that are allowed to access the bucket. That's about it, right?
The admin creates a selector, but yeah.
Yeah. And goes and sets it on the namespaces too. Like he sets the selector here and then sets the labels on the namespace objects.
If he wants to do it by label, he could just do it by namespace name.
So we're doing two things then. Then we're doing it by label and by name.
I don't know. I prefer a way to do selection directly on the name and not have to worry about labels. I mean, I think labels is a nice additional flexibility, but I don't want to force everyone to use labels.
Fair enough. I think in that case, since it's mutable anyways, since this is one thing in buckets is mutable anyways, I mean, we could just use names and just move forward the way it is right now.
You mean a literal list?
Yeah.
Of names? Well, yeah, but I mean, we can. Nothing's stopping us. But I do buy the argument that a selector is cooler. And
no, selector with names is kind of weird to me. Other than that,
did we lose? Oh, we lost Guy. Guy was the one who was proposing a selector with both match labels and match namespaces on Monday, and we lost him.
No, he actually clarified and said that he wouldn't actually have names explicitly. I mean, we could come up with an expression, like we could come up with a match name kind of thing here. We could have match labels, match expressions, and match name. Why not?
So the issue was, I think, we had a thread going on Slack. So I'm imagining three buckets, right? One is accessible to Alice and Bob. Another one's accessible to Bob and Charlie. The third one's accessible to Alice and Charlie, right? So with just labels, the only way to do that is to have three different labels. Now if I want to create a fourth bucket that's only accessible to Alice, I actually have to create a fourth label to do that. And like it gets combinatorially weird to support different combinations of namespaces for different buckets only using labels.
Don't we do it for every other resource though?
I guess.
I can't find that thread.
It's the one that Guy made, yeah. That should be like the second or third comment, I think.
It was, yeah, it's the one that was right after the yeah, there it is. Yeah, this is it. Alice and Bob and Alice and Charlie. So yeah, I think Guy said.
Oh, he does? Yeah, he did mean match names. Match exact names.
Yeah.
Okay.
Yeah. I mean, I don't know how weird that would be from an API perspective, but I think having both gives you better flexibility.
Yeah.
I don't have super strong feelings about this. I just doing everything through labels feels like it could put you in a weird spot. At a minimum, it requires that anyone who wants to be able to grant bucket access to namespaces must have modify namespace access in their in their service account, which is a pretty powerful role to grant to a controller to be able to modify namespaces. So if you can just directly enumerate namespaces in your allowed namespaces without requiring labels, it allows you to do this without having that RBAC power of mutating other people's namespaces.
I think that's a good point, Ben.
All right, so okay, let's just go with this then. So I think other than this, there's only one more thing that needs to be resolved then before we, go ahead. I mean, I think we can go ahead and talk to the API reviewers right away. The one open question that I have is something that Jeff brought up about bucket ownership. So Jeff, do you want to explain? Oh, we're almost out of time. We can have this discussion on Monday. But Jeff, in the remaining time, if you want to give a quick intro to the issue you were talking about in the Ceph driver.
Yeah, I'll just put a link in SIG Storage Cozy for you guys to read when you want. It's just one small couple of paragraphs. Bucket ownership comes up a lot, and I think Jiffin might still be on this call, but we're writing a driver for Rook Ceph for Ceph RGW object store, and our Ceph object store supports some user-based policies, and one of them is quota. So quota per user, or per, and it keeps coming like, who's the owner of the bucket? And our answer's always been, well, essentially the driver is run with some credentials. Those credentials are used to become the owner. The author of the BR is not the owner. The driver is essentially the owner. But that makes it very hard to support user-based policies on the backend bucket. And so that's what I try to discuss a little bit in a few paragraphs, which I'll send you a Google Doc link to.
Yeah, I've seen that kind of problem all over the place in Kubernetes, where you have tenancy at two different levels and somebody wants to map them to each other when that's not a natural thing to do.
Yeah.
The answer I would give, like if someone wants to control quotas on buckets, what you really need is Kubernetes quotas on buckets, and
right.
that can be enforced all the way down. Like, so if Alice asks for a 100 gig bucket, you decrease Alice's quota by 100 gigs and give her a bucket that can't exceed 100 gigs.
Yeah, and we have the quota system, and you could control number of resources created, number of BRs or number of Bs or whatever, and then size. As long as we put in that, you could do that. The BR would have to support, or the BC something would have to support a size. But anyway, this is very incomplete. It's just some thoughts I had recently, and I'll just share the link in SIG Storage Cozy.
Mm-hmm. Thanks, Jeff.
Sure.
Yeah, please, please go through that doc. It's very well thought out, and leave your comments, and we'll discuss it on Monday.
Sure. Yeah.
Are you sharing the doc somewhere?
He's going to put it on Slack.
Oh, okay. Thanks.
I'm going to in the SIG Storage Slack channel, SIG Storage Cozy Slack channel.
Okay.
All right, so this gives me enough info to go finish the KEP and reach out to Tim again.
Yeah, I just pasted the link in SIG Storage Cozy. All right, Sid, thanks. I got to run now.
All right, I think it's time up. Good discussion today. By before the Monday meeting, I'll have the finished out KEP, and on the Slack channel, and we'll have the next discussion, and we'll go from there.
Thanks, everyone.
Thank you.
Thank you.
Thanks. Bye.